Okay, good morning, everybody. I'm Miko Dicini. This is SYN116. We'll talk about how customers manage Citrix Networking for cloud-native applications. And with me is Ritu Sharma. Ritu, could you introduce yourself?
Yeah, I'm Ritu Sharma from Duke Energy. I'm an architect with a focus on infrastructure and operations.
Before we start, show of hands, anybody here who has Kubernetes microservices projects? Show of hands, a few. Who are here just wants to learn about this technology as well as the transformation that companies go through because they're probably in the process of going the same thing? Thanks, that's good to know. Great. So today I'll talk about how do companies do this, right? Part of it's really a process change, a business change around digital transformation. And I'll talk about the rise of, I call it the platform teams, and I'll explain what that means. And then a customer journey, what our customers go through as they move through this process and deploy Kubernetes platforms. And then an example of Duke, which I think is the main part of this presentation. So let me start. So when I talk to companies, what I find out is that they want to move fast. And so it starts like this. I have this stick diagram, like a CEO says, hey, I want to move fast. I want to get closer to our customers. It's about customer engagement. And to do that, they want to be able to connect to them by building apps, custom apps, mobile apps. Essentially, these are apps. And so this, as chief product officer would say, I want to build mobile apps. We'll get customer feedback, and we can modify the apps, and we can move quickly. The challenge, though, is that there's some obstacles. One is that the developer will say, hey, I want to deploy this app. And the networking team may say, well, it'll take me 2 months to deploy the app. It'll make me weeks to get you a load balancing VIP, for example. So it's going to take some time. So that's a challenge. How can you move fast if the organizations are siloed and therefore can't move at the speed of the business? So what happens, though, is that I see this happening is at the executive level, there is a decision made to change. And that's part of that is how can we move fast? We need to look at our business processes, business people and tools, and impact a change. And in terms of process, it also comes down to the architecture and the applications that they write as monoliths. They break them into microservices so they can move fast. And typically there's an architect as part of it, so that an architect helps them and look at the architecture and also look at the whole set of teams involved in deploying these applications. And so what happens then is there's an insertion of a platform team and a project in place to transform the organization. A platform team is a team that actually runs the microservices platform, container platform. Typically, it's a team that runs Kubernetes. Kubernetes is a solution. It's a distributed platform that Google had open sourced and many companies have contributed to. But the point here is that there's a platform team that owns a microservices platform. It's typically part of another organization. Probably it's part of the CIO organization. It could be part of the cloud ops team, or it could be part of the enterprise compute team. But their role is specifically designed to run all the Kubernetes projects, and it's composed of architects. And typically there's a middleware architect because there's a need. Typically these middleware architects are the WebSphere people. They deploy the web apps. And so they're familiar with applications, and therefore they're the natural place to provide the responsibility for running a platform. And with that, there's also a DevOps person, there's a security architect, and a platform admin. And this platform team typically seek enterprise-grade solutions. All right, so what's their desired state? What do they want to do? One is they want to decouple the apps from the infrastructure. And you do that really by not using VMs, right? Because VMs is tightly coupled to the hypervisor. So they use containers. Containers are very portable. I can run them on-prem, I can run them in the cloud, so they use containers for that. And you want to decouple teams from one another. So to decouple teams from one another, you want teams to work on their part of the app separate from other teams. They can use their own programming language. They can deploy the apps at their own speed. They can update the apps at their own speed, and so on. So that's another goal. The other goal is they want to decouple the application development process from the operations process. So a platform team runs the platform. They update the platform, provide policies on the platform, and the application team deploys apps on the platform. So So this showed the desired state for the platform team. It looks like this. So this came from Gartner. So Gartner provided this diagram. The point here is that there on the far right bottom, there's a container cluster that can be on-prem, it could be in the cloud, or both. It's hybrid typically. And there's two paths. There's the app development path on top, and there's the infrastructure and operations path below. So, and the infrastructure and operations path is really about managing the platform. So they provide policies, they upgrade the APIs, they upgrade, they make sure it's secure, provide templates. That's what this path is, right? And the other path on top is the application development path. So they're the ones who use the platform, they deploy the apps, and they're given ways for the developers to deploy apps using an interface. And there's a whole set of tooling that goes through deploying apps to this platform. And the platform can be, like I mentioned, on-prem and in the cloud. Okay, so far? Any questions? Right. So how do you insert that platform in a data center? So I've drawn here a typical 3-tiered architecture. I'll compare that to the cloud-native architecture. On a 3-tiered architecture, typically it looks like this. There is a ADC team on top, ADC on top. There is a compute hypervisor, and the apps are on top. You just load balance the apps, off you go, right? In a cloud-native environment, there is a platform that gets inserted, and it's typically Kubernetes that gets inserted. And there's an ADC on top, run by the ADC team. There's a platform, again, run by the platform team. And inside that platform, there are load balancers as well, called ingress load balancers. That's run by and owned by the platform team, but given to developers. They're made to be available to developers so they can run at their own speed. And then there's another team that runs the compute and hypervisors. That set of load balancers is similar to the one on top, but it's software-based and it's inside the cluster. So that's just to make it very straightforward. Typically, what happens when customers make this journey, they spin up open source tools, open source Kubernetes, open source load balancers, and they run into problems when they start migrating their apps. They have a bunch of legacy apps that run on TCP, for example, and to move them over, what they find is that open source load balancers don't support these apps very well, which means they have to architect these apps, so that's a problem. So that's when typically we hear about the situation, so we get involved. The second thing is that as they deploy these apps, they need to transfer policies, security policies really, from the existing load balancer down to the Kubernetes cluster. And these open source load balancers don't support the extensive policies available from a Citrix ADC down to the ingress load balancer. So, okay, there's a limitation now. How do I put all these rewrite responder policies to enforce, let's say, SSL traffic? That's very hard to do. Finally, if you want to operationalize this load balancer, you have to buy support from an open source vendor. And you do that because you need to patch the load balancer, security patches, update the ciphers, for example, new versions, new features, and so on. Make sure it's compatible with all the Kubernetes ecosystem. And that typically is a challenge. And so what happens, though, is that these platform teams, they essentially look for a production-grade solution. And what Citrix has done is that we've looked at the limitations of what's available in what's called an ingress load balancer, and we've added more functions to the specification. So straight off from Kubernetes, you get a limited set of functions as described here, primarily HTTP-specific functions, and HTTPS, and routing, and TLS, and load balancing. What we've done is we've extended it to support legacy apps, so UDP, TCP, SSL, TCP, added additional ways to do DevOps by doing canary, extend our policies, making them available as APIs to Kubernetes, like rewrite responder policies, added authentication, added WAF, and we're going to go even further, adding more functions. So we actually expanded what's the definition of a internal load balancer called ingress to what you really need to use to deploy your apps in production. All right, and then so we have products in this space. We have an ADC, multiple types of ADCs. As you know, we launched the BLX today or yesterday. We have ingress controllers, we have ADM, and we have integrations to the ecosystem. We have integrations to CNCF projects. We have integrations to cloud-based Kubernetes. We have integrations to enterprise-grade Kubernetes. So with that, let me bring in Ritu, who will talk about their experience at Duke.
All right, so a little bit about Duke Energy, how we took this journey and where we are. So we are Duke Energy. We have been in service for over 150 years. We are the largest utility providing all power from all different areas, even fossil. We are trying to cut that down, of course, nuclear and all that. So we have 7.6 million electric customers. We have 1.6 million natural gas customers. And so really what this is all about is we are transforming. We are seeing that we need to transform. We are very customer focused. We are very dedicated to our employees. So Duke needed to take this journey, and as we are transforming our customers' experiences, we are modernizing our energy grid, generating cleaner energy, and expanding our natural gas infrastructure to create a smarter energy future for people and communities that we serve. So as we know, as we talked about, our industry is changing. We have very low or almost no growth, impact to the Duke. Why is that? Because we are seeing solar, wind, battery storage, and some of the self-generation. All those things are impacting our Duke's business. So our customers' expectations are increasing. They are needing more mobile applications, the way to interact with our company, to pay bills, to look at their data, to look at their consumption, and to maybe conserve energy. So they are looking for more and more applications that we need to provide to them. And that's where we know technology is becoming very, very infused in every aspect of this business. As I talked about, the disruptive innovations are driving rapid change. So Duke Energy must transform to stay ahead of industry changes if we want to win business, if we want to stay on the top. And we have to transform accordingly. So as a critical enabler of the company's strategy, we know IT must transform. IT is not about IT, it's about business. We have to help business. So keeping all those things in mind, we must provide high quality, reliable, innovative technical services, both at a rapid pace in a very cost sustainable manner. So keeping all those things in mind, being faster, cheaper, better, we have to be. Duke started this initiative called LIFT. It was really with keeping IT in mind for the business that is up and coming. LIFT is Duke's IT's transformation program that will fundamentally improve the operations and deliver the sustainable cost. We will deliver a culture of empowered employees and who work across organizational boundaries and drive business outcomes. We wanted to get out of silos. We needed to be leaner. We needed to be agile. We need to be shifting left. We need to keep DevOps in mind. And of course, manage our supply chain.
Rita, before you continue, can I go back to the previous slide?
Sure.
Just so to add, so basically what happened was that you're saying there's a lot of requests to the IT team for projects as the business needs to do more things, and you discovered that it's hard to do.
Right.
And so the executive leadership decided let's figure out, let's look at tools, processes, and platforms and people, and figure out how can we approach this in a very logical way so we can do more things with the people we have, right? So that led to this initiative where essentially you became a software, almost like a software company. You adopted agile process.
Correct.
You've moved people around. You even use Jira, from what I hear.
Yes.
And then with that, you've been able to push apps faster from what was perhaps months and perhaps years now to maybe days and weeks, right?
Exactly.
So can you just walk us through these parts of this, right? So you adopted DevOps. You eliminated some ways, you took some processes out, and then therefore, and you also moved people around. Can you just talk about perhaps the people side?
Right, so just like any big company, we are very siloed. I'm in IT operations. So even in IT operations silos, you got silos within silos. So some people are just doing primarily compute. They are storage people. If we need, if we request a VM people will go to storage and they say, give me some storage. And then we will go to our networking people, give us some IPs. We will go to all different areas. So that's the process, a very sequential chain process where we created tickets, waited for people to give us things before next process can move on. That's the way we were. So we took all that out. We said, as I'm going to talk about the timeline, our CIO basically said, this is not working. We are so all bogged down in the paperwork, we are really not doing any service to the business. We are just delaying. It takes months and years to get a project started. So that's when this initiative was launched, and that's when we said we all need to be DevOps, not just DevOps, DevNet, Infra, NetSecOps in every way, in networking, in security, in infrastructure, in operations. We all need to be agile. We all need to create. We all need to move left and automate our processes. So we all need to be leaner, manage resources better. So that's how this lift process started.
I think it's a new term, DevNetSecOps.
Yeah, DevNetSecOps. Yeah.
That's great.
So, all right. So this is just a timeline of the journey we took. I'm just going to fast forward that way. We started really, as I talked about, in 2015. We started small projects in 2016 based on the new methodology, and then we expanded to large projects. Our CIO basically said in 2020 we'll be fully agile. That's the way we changed our culture. We changed our processes. We are still learning through that. It's not easy. It's hard. But we took the people out from their silos, from their comfort zones, from their level, and they said, you are going to be customer focused. This is the role. We have customer focused application teams. We have teams where we call data center and integration team. We have people from network, from as I said, from middleware, from compute, from storage, from provisioning. All those people came to an agile team. So our goal is to completely transform the way we used to do things. So now, this is just the background on the culture. Now I'm going to start getting into some of the technical issues, what all the journey we took, where we came from, where we went, where we are today. So as we talked about, as Miko talked about, we know cloud journey starts with containers, being agile, being fast, and all that. So containers and microservices, they play a very big role in there. And we need to adopt a DevOps culture. We need to leverage open source and innovation. Basically, if you think of, if you are in your companies, being in Duke, I mean, we were told, you cannot do any open source product, cannot use open source product. We were paying, of course, millions of dollars. We are a very big shop of WebSphere and WebLogic. We have monolithic applications, hundreds and hundreds of applications running on WebSphere ND clusters. And it takes a long time to do the patching and upgrade and planning from version to version and all that. So that is what we are today. But as we started to how to become agile, how to get there, we need to concentrate, we need to focus on containers and microservices. So as we talked about, the challenges that we looked into, we know we need to drive for innovation. We also need to keep an eye on disruptive technologies. We need to work towards digital transformation, Internet of Things, artificial intelligence, hybrid cloud is on horizon. We need to deploy to hybrid cloud, not just on-prem. We need to do off-prem. We need to do a combination of both, because that's a very critical component of the moving forward process. So as a dynamic business, we need to make sure we are automating, we are integrating and making an effective use of resources for all key areas. We need to encourage automation. We need to encourage agility. And as we move forward, we still have a big base to support for legacy applications. We cannot forget that we have to maintain Windows 2008 going away. Soon Windows 2012 will be in that boat. What do you do about those applications? How do you take them forward? How do you modernize those applications? And of course, we have CARTS application, we have in-house written applications, but we buy off-the-shelf packages. We need to provide a platform to run and deploy those applications. And of course, we need to meet our DevOps team's requirements. We need to have CI/CD pipeline, full integration from end to end, from your Jenkins, Maven, Nexus to all the way deploying and being able to update applications faster. So we need to include all that. So those were the challenges we were looking at as we started to take this journey. So once we did that, you said, okay, now we know what the issues are or where we want to go. what is the direction we want to take? How do we focus ourselves so we are just not getting, not going nowhere or getting confused? I know we want to be agile, but we want to also give ourselves some focus on that. So we said, what is that we want to do? So as we talked about, we said we want to focus on open source, open standards, and we want to avoid proprietary technology. We want to avoid vendor lock-in. We want to have a well-designed architecture that provides flexibility. We also want to have, many different alternatives, plug-and-play technology that can be used in multiple places. And we all of us have a big investment in the network and load balancing and monitoring and logging already. How do we also utilize that and not spend so much money that we are changing every little piece? Maybe we can take advantage of the existing technology. Maybe we need to go to our vendors and say, how do you provide to move forward in terms of container management and how the monitoring, how the load balancing will work? So we want to go back to our vendors and ask those questions. And so, of course, focus on end-to-end automation with security built-in. So when we started this journey, security also has to learn along with you. They don't know, they haven't done enough research. I mean, someone has to start. So what does it mean to run containers? What does it mean in terms of cybersecurity? How your platform and how your networking and how the ports and all those things will be managed? How multi-tenancy will be managed? How applications will be talking to each other? So that's where you need to make sure you are integrating the security from the very beginning, and that's what we did. So we have to keep that in mind, integrate security, integrate DevOps tools, and maybe automate some of the processes which are not there before. And the other thing that we started to look into, so once we realized our challenges, once we know what we want to focus on, we also wanted to make sure that we are making the right decision. And that's where some of the research and some of the people that you need to talk to, some of the articles that you need to read, and go by a little bit on your gut feeling. So what was happening at that time? Kubernetes was just coming up. It wasn't what Kubernetes is today. People started, when they heard containers is good, we want to do containers, but how do you go about doing containers? Containers, we were hearing it's a Docker. There are a lot of internal research on that. So Docker technology, so people thought Docker runtime meaning Docker Inc. Now Docker Inc. provides, it was the owner of the Docker runtime, but of course it became a, open source and all that. So people sort of thought they are together. So when I started to look at, when we are doing containers, should we do Docker Swarm? But as we looked into Docker Swarm, I was finding some drawbacks in there. Their networking, the CNM versus CNI, if you read up on that, is the container networking interface. This definitely was better with the Kubernetes, what was on the roadmap. It was all on the roadmap. But that was more promising, that was more progressive and outgoing, and that's where more focus was going to be as I started to do some research, and as compared to Docker Swarm. And some of the auto scaling of your containers, dynamic agility, that was missing in the orchestration with Docker Swarm. So some of those things came along, and we basically, also other thing is that we have PCF in-house also. So we wanted to provide a complementary technology. If you have PCF, you are already doing, right? It's a little bit proprietary containership built in there, but it's good. It's good for development, but it's very rigid. It's not flexible. Of course, the containers in Kubernetes is very flexible. So, but we wanted to provide a complementary technology and not a competing one, because we had made a big investment in PCF PaaS. So keeping all those things in mind, we made a running list, a brain dump. This is our focus. This is our direction. This is what we want to do. So knowing all that, we gave ourselves a mission statement. What is that we are about to do, and what eventually our goal is? We said we're going to provide an infrastructure that is hybrid, modern, open, and engineered to run containers for legacy and greenfield applications, and with integrated security and agility. So knowing that, what does that mean? How are we going to put together that platform? This is what we're going to see. Eventually, this will all result into improved efficiency of IT processes, greater consistency and quality, faster time to market, greater scale and innovation, and of course, greater synergy within IT silos. So that was our vision at that point. So
yeah, before you continue, so you decided to go Kubernetes.
So exactly.
And then you wanted to work with a enterprise-grade platform.
Correct.
And at the same time, you had multiple data centers and you wanted to deploy a hyperconverged platform.
Very good point.
And you merged them together.
Exactly. So give a little bit background what Miko is saying. Yeah. So once we knew this, we had to look at what we have today. We got a couple of big data centers, but we also have multiple remote small data centers. And a little bit background on that, how we also started looking at containers is that I'm in operations architecture as an architect. We always look 2 to 5 years ahead. What is coming? It may be, tomorrow we're going to Mars. Is that something coming in 50 years? Maybe, or 10 years? So what is coming in 2 to 5 years? So containers were on the horizon, and hyperconverged infrastructure was also starting to come up. Hyperconverged infrastructure, as you may know, is it provides your compute, your storage, your networking. It's everything in a box. You are not putting the pieces together. It's all in one. That makes your job easier. So when we looked at our remote data centers all over, we thought hyperconverged infrastructure can be a good thing for us. Good use case. So we started researching. As I said, I was researching on containers. There were people who were researching on hyperconverged infrastructure. There were other people who were, researching the storage, because that's our role. We want to look ahead what technology is doing. So as we were very confident that a hyperconverged infrastructure is something we want to start rolling out in company. So when we did that, as we started to look at the vendors, we decided we're going to do Kubernetes. And we're going to do all those things. So as we started to look at different vendors, there were vendors which were doing some of the, OpenShift was obviously there, but OpenShift was very competing with the PaaS, PCF's PaaS thing. So we didn't want to sort of bring OpenShift. They were very similar. It was coming up. So as we started to look at different vendors, we thought about, should we do all in one vendor, right? A single vendor providing the whole support. Docker Inc. is in there. There are a few others. We also look at SUSE's containership. We looked at, we looked at about 5 vendors. We created a criteria. We gave ourselves a weight, how much weight each criteria has. And we held about 3 to 5 POCs. We work with vendors and say, show what you can do. We want to deploy it in an in-house app, in-house written app. We want to deploy a cards package. And we want to maybe deploy, we also deployed the SQL database, Microsoft SQL to 2017, which was coming up as a container image. So when we did the POCs, we asked all these vendors, in the POC, to see what it will look like if we do all these deployments as a container. So that's where one of the things that we looked about, knowing the hyperconverged, knowing infrastructure, we sort of started, we were digging. So we looked at Diamante. So if you look at Diamante, it's a full stack. They provide the storage, the compute, the networking. They provide the Dockers, the Kubernetes, and not only that, other thing which I want to mention is that we want to be HA. Highly available. We have multiple data centers. If we want to have active applications running. So if one data center goes down, it's not just that one node goes down within one data center. You want to design an infrastructure. If one data center goes down, are you still working? Are your applications still up and running? So we were looking for a solution that is fully HA, even for persistent applications. Some of us, we know, stateless applications, those can be easily done. But what about persistence? What about statefulness? What about your databases? How are you going to containerize those in a multi-data center environment? That was our goal. Our goal was to have that available. So when we saw that, we saw all those things that Diamante provides. We talked to some of their customers, and they were running databases on Diamante container platform. They were running very critical applications. So we did a POC with that. So that provided us the Docker, the Kubernetes environment. But it's also multi-tenancy. So we said, okay, this is how do we go about adding a control plane that will provide a deployment methodology that will provide us a way to do a multi-tenancy using the Kubernetes. So we looked at Nirmada. That is a control plane. It's completely plug and play in a sense, completely open source. You can add that in front of your bare metal Kubernetes infrastructure. You can add that in front of Azure, in front of AWS, or your IaaS, or PKS, or even Red Hat OpenShift. You can take any backend platform, Kubernetes based, and you can go through Nirmada. What it does, it onboards your clusters. Once you onboard your clusters of any of these platforms I talked about, then you can add users. And that is, users can be your Active Directory based, your LDAP based authentication. When you log into that, that's the administrator can create that. Administrator creates an environment. What does that environment means? It means a namespace. Some of us who are working with Kubernetes at this point, namespace is the one where your pods are running. Pods are the terms with Kubernetes for containers. Containers, multiple containers in a pod, pods in a namespace. So it starts from inside out, or containers, pods, and namespaces. So what it does, it manages all that. You can create an application in there and deploy. It's a click and clack GUI. You can create, you can add storage, you can add anything you want. You take a YAML file. Some of us, as I said, some of us who are working with that, we know what a YAML file is, what all the things go in there. So you can create your application in there. It will generate a YAML for you that you can save and export and put it in your repository. Or if it's a carts application, you already given an image, a container image, and your YAML files, you can import it in there, and you deploy to the namespace that administrator will create for you. And in the back end, you can be deploying that to Diamante, your on-prem platform or PKS platform you may have, or you are connected to Azure, AWS. Through this control plane, you can deploy. And the good thing about that for the development side is that they don't need to worry about it. Developers have enough on their plate. There is no such thing as no ops. I know in the timing we heard no ops, it's all DevOps, development teams are going to manage that. That is not true. And that's where container as a service, we saw that. It's really a very good blend of where your IT ops people and your DevOps people can really work very well together. Everyone is doing their own job. So as we saw, this provided us, we didn't want people to go and shell to, and do kubectl commands, and security was not going to let it happen, because these are big, huge bare metal environment, Diamante, and you need to provide multi-tenancy. You need to provide a way to roll, RBAC, to authentication, authorization, and isolation of all those different business units which are part of that. So we looked at Nirmada and we put it on that. We said, can you do a PLC for us? And so they did. It was a very successful POC for us. Now we started looking into, hey, okay, we got a platform. We know what we can do, we can use. It's good. We got a control plane that we can use on top of it, as Miko talked about, load balancing. He said, how is your container routing and load balancing happening? That's your east-west traffic. We knew what to do with the north-south traffic. We have a strong team in-house, very knowledgeable. We depend on them. But so we were good at that. But we wanted to further invest into that and say, how do we are container routing? So that's where we approached Citrix and said, okay, we have a container environment. What should we do about our container routing? So we worked with you, Miko, and then we came up with the plan, right? This information is available on this, and this is actually old. Now all the names have changed, correct?
Sure, yes. So the Team A, Team B. It's part of our demo apps. But
Right. So ADM and ADC is NetScaler is ADC.
Citrix ADC now, yeah.
Citrix ADC. And so this is the part that we did the testing. We are in the process of rolling this out. And that's where Citrix, provided us a lot of help in there. We came up with the design, we came up with the process, and a lot of new features you talked about.
We did, yes. So actually, let's talk about a little bit, right? I think one thing was that you had legacy apps you wanted to move over. So you needed TCP and TCP SSL. You also wanted to provide YAML files to Nirmata so it can automatically configure the CPXs, and
yes,
that's what we provided.
Correct.
And the other one was you wanted apps to go east-west to be secured with SSL.
So a little bit talk. So I have a reference diagram. I can talk about that. So let me talk about that. So as we added the Citrix NetScalers on top of that, this is something putting it all together. This is actually this is what we are doing. This is what we are using. So as you can see from there, we got Nirmata control plane. We got Kubernetes, cluster in 2 data centers, stretched completely HA, completely with DR. We ran through, chaos monkey methodology. We turned the nodes down. We unplugged our nodes. We even took the whole data center out, and we wanted to see how our applications are behaving. So this is the plan. So as you can see, they worked very well. I mean, we learned a few lessons. We have to tweak a few things. We have to work with our network team, some of the switches and ports, their configuration, the storage configuration, your network configuration, your management VLANs, your container VLANs. We had to sort of plan all that out, and we had to go and tweak some of the things. But that was the part of it. Once we invest that time, we know this will be on autopilot. So as you can see from here, we have ADFS. This is a single sign-on. You log on with your single sign-on to Nirmata, and behind the scene we onboarded Nexus registry, and Jenkins and Nexus our DevOps people are using. For the container side of things, we had a lot of investment in Splunk, and we have had investment in the CA monitoring. So we went to those vendors. Can you provide a monitoring for that? So CA provided, they worked on it. They gave us a way where we are deploying. Again, the part that I want to mention over here is containers are not just for applications. Containers are for infrastructure. We all in IT ops, we ourselves are doing DevOps at this point. We are deploying Citrix CPX. We are deploying Splunk. We are deploying AquaSec, which is our container firewall, container isolation and segregation. These are all containers. These are not any other applications. These are all containers, and they all go through the same DevOps pipeline as a developer application will go through DevOps pipeline. There is no different. So that is the beauty of that. We all are becoming DevOps. So other thing I mentioned, so this is our load balancing east-west traffic. This is also deployed as a container. This is CPX, Citrix CPX, which are nothing but you deploy as a container. And then, as you can see, so as if the applications are coming through Nirmata, deployed to this, ingress is all automatically set up. If they can do all this in Nirmata, because what happens, we have wildcard URLs. So once you create the wildcard URLs, the wildcard WIPs, you can automatically create the URLs. If I say *myapps.duke-energy.com, then you can say app1.myapps.duke-energy.com. You can prefix and dynamically create URLs based on the wildcard WIPs. And so you set these up one time, and that DevOps, if you have a business unit, for example, we have, let's say, customer business unit or a outage management business unit. So we create a WIP for them and one time, and they create multiple URLs out of that. All on autopilot. You don't get involved. So as I said, we still, as the request comes through, it goes to the VPX, the whole Citrix SDX VPX infrastructure that we have in place. And then once it goes through, then it comes inside After setting up through Nirmata, it comes inside the Diamante platform. It can be also Azure. And then we set up the ingress over there using the CPX, and that's how your application is accessed through browser. And as you can see, our next thing that we are working on, we have onboarded an AKS cluster on Nirmata. We are in the process of setting up the load balancer that will go across Azure and on-prem and off-prem. This is the work we are in the middle of doing. But this is really our whole diagram that we utilized, where you can easily bring new applications, onboard anything. You can add capacity, manage capacity on demand, but go through Nirmata and deploy using to your backend Kubernetes clusters.
Great.
All right, so just quickly, so this is our DevOps pipeline. As I talked about it, our goal was to utilize existing processes. This was already in place. So what we did, we added Nirmata in there. This is just another piece. We are still managed using our standard operations DevOps pipeline that we have, and then we added Diamante over here. So this is in a company, we are not disrupting every little thing. I think that you will not be successful if you make a change where you're not utilizing your existing processes. So as I said, all those things I talked about is journey. The time it took for us was very fast. Once we realized, once we did the POCs in 2017, in 2018 April, we decided this is the architecture, this is the design we want to go with. We purchased our hardware, we did some training sessions, we got all these environments set up. In November, we did our first dry run. We deployed applications first time in December, and we let it sit. We said, okay, environment is ready, everything is ready, applications deployed. We did not quite open. So when we got back after New Year's Day and all that, so then we opened those applications to users. And then, as you can see, by end of March, it has grown even more. We have 113 applications in development. We have 80 users. At the time, we have 19 applications in production, 60. We have about 25 or so applications today running in production. The timeline, if you look at how fast this is, this was the thing we had to do. We wanted to be agile. If we were going to fail, we were going to fail fast. We needed to do it. Yes, might as well fail and know about it, not take months and years and know, gosh, we made a mistake. And again, I want to mention that we were able to do that because our leadership and all that, they empowered us. Some of the journey I talked about, the lift, they said, we trust you, get us there. And we did. And so we wanted to, if we were going to fail fast, fail forward, restart, redo. So, but luckily we had enough in there. We did our research and all that, and we had good partnership with all our vendors, with Citrix, with Diamante, with Nirmata, with CA, with Splunk. We went to each and every one of them and said, we are doing this initiative. Can you provide what you do for containers? And everyone really, they were excited. This was a new technology. They were very, very, very willing to work with us because that's their business. They want to be the business providing their technology to their customers. And there is a customer asking for it and said, okay, we'll work on it. So it went pretty quick. So just quick summary, right now we had 8 clusters, about 76 nodes. We got 4 Nirmata instances. At that time, it's about a month old, 100 some applications, 80 some users. And we have, this is a little bit of picture. We have a staging environment, we have development, which, 2 clusters of development, 1 cluster of test, 2 clusters of QA, 2 clusters of production, fully HA, fully DR, stretched in 2 data centers. So what went well? The training, the knowledge, along the way, we provided training to our DevOps. We got ourselves trained. We did the project planning. We did the collaboration with our vendors I talked about. We wouldn't be successful if we were not going to them and asking, hey, work with us. Quick resolution of the issues. High availability and recovery. Your business will come first, but if you are, as an operations architect, as an operations support person, business will also run away pretty fast. If the day 2 is not working, that's the end of it. You have to plan for day 2. You have to what happens when things go berserk, when things are not working, when you are sitting in SDEs, when you are on phone, when your management and everyone sitting in the room and saying why things are not working. You have to plan for that. You have to plan for high availability and for that support. So yeah, we said use existing tools, communicate with your partners, plan well, cross data center deployments. Rollback is very important, extensive training, staging, dev, QA, make sure you have all those environments, proactive monitoring. So that's how we took our journey, and that's where we are.
So I think we have some time for some questions. It's lunch afterwards, so we have a little bit of time. So if you have any questions, there's microphones on both sides. I think we have 5 minutes, maybe. Any questions, comments, thoughts?
Yep.
Hi, Phil
Phil, yeah.
with Citrix. What was the time or time period, and why did you move away from Cloud Foundry and to Kubernetes?
Move away from Cloud Foundry and Kubernetes. Yeah, I think as I saw, we were looking at, there were some restrictions. Our developers were saying, I cannot work in the schema of the things, what is provided. They wanted flexibility, they wanted control. So that's why we started looking at Kubernetes and containers. But we haven't quite moved away. We have a room for both, right? We have both platforms in-house. There are certain use cases better suited for PCF PaaS. There are use cases better for Kubernetes containers.
So you didn't eliminate PCF?
We did not eliminate. We have both in-house, yes.
Okay. You had HA proxy and CPX as part of your infrastructure in there.
Correct. So
what are you deciding to use? Which one for what purpose?
So as we were working with our Citrix partner over here, we were a little ahead. So we started with the HA proxy, but you saw there are some limitations in there. So we are rolling out CPX right now. Our goal is to really be CPX. We're going to retrofit. As the new apps come, they're going to go on CPX, and they're going to move the old apps to the CPX at some point. So. Yes.
Hello? All right, great. So what are your plans for the next step? What is coming up now when you're in production? What are your thoughts of the future?
Very good point. We are looking into the next version. Actually we are looking at Windows containers. That is the next thing. As you know, Windows containers can be done. Your master in the cluster has to be Linux, but you can add your Windows node and manage Windows node from the same cluster. So we are looking into that. We are looking at the Istio service mesh. We are looking at the next, as we upgrade our Kubernetes version, that is something we want to invest on, because I do think it's going to provide better functionality to us for some things. So that is what we're going to focus on.
Thank you.
Sure.
Sorry.
Come on, yeah.
So you have Diamante as your on-prem
Correct.
Hyperconverged?
Hyperconverged bare metal platform.
And in the public cloud, you're just leveraging, like for Amazon,
Yes.
EC2 instances?
Exactly.
Okay.
We are working with Azure right now. So we are using their cluster. We can provision our cluster too. We want to try both options. But definitely, I think more leaning towards these vendors providing us the cluster. So we have our nodes which we have control over, but they manage the master in the Kubernetes cluster.
And is it one single instance of the Nirmara product?
Nirmara.
Nirmara that front ends both the on-prem and cloud?
Yes, exactly.
Okay.
It's a single instance that can onboard any of those. But we have 4 just because, some of the security, cyber security, compliance rules keeping in mind, you don't want to deploy from dev to QA some of those rules. But otherwise, a single instance will work everywhere.
All right, last question, I promise. Are you currently leveraging the additional features of our CPX beyond what HA Proxy or Nginx could do already? Like, are you
Yes, we have a major project looking to do. I think we will go on CPX. They have certain things, how much control they want on their WIPs.
Yeah.
So, even authentication, authorization, some of the, do you want to have pass-through? Do you want to have termination? All those kind of things. So, yes, we are looking to follow on that, yes.
Like WAF features as well?
So the WAF is possible. As I talked about, we have AquaSec security. AquaSec is your container firewall isolation. You can create firewalls within parts. So for multi-tenancy, so this namespace will not talk to this namespace. So I think we want to compare what WAF and RASP provides in combination with the container security firewall that we have implemented. So we want to see what will work where, maybe use cases for both.
Okay, thank you very much.
Sure, thank you.
Isn't Aqua security for like security within, but not from the outside?
So AquaSec security are the containers deployed to the Kubernetes platform on the Diamante platform, right? And they are that's where you create the firewalls. But outside of that, we have Palo Alto. We got VLANs. Container VLANs are set up for different. And so those container VLANs are segregated from other VLANs. Your QA VLANs are separate, your dev VLANs are separate, prod are separate. That's where we have Palo Alto. So we have external security, but then you got your internal security. And the part that I did not mention is the scanning of your images. We have DevOps, where we have Nexus and Sonar type, where when we download our images, they are deposited in the repository, and then they are scanned. And AquaSec also provides you the scanning of your images and the report, what your vulnerabilities are found, where the problems are, and the reporting on that. So we are secure on multiple levels. A container level, higher level, VLAN level, firewall level. So that's how we are doing.
Question on the left.
Yeah, hi, my name is John. So where was the Citrix control plane? Was that dedicated in the container, or?
I can answer that.
Yeah.
We have CIC, we have an ingress controller, which is a container. It resides in every CPX. And by controlling an external NetScale, we have a separate container for that.
So the Citrix control plane was in a separate container?
In the case of CPX, it's part of CPX.
Oh, it's part of CPX?
Yes, yeah.
Okay. And so within that control plane, the various workloads are there, various Citrix silos, the VDAs were sitting in that container as well?
So was there VDAs? No, I don't think the question is VDA. So I don't know, are you using VDAs inside the application? Not quite yet, no.
Yeah, no, but we have multiple ingress setup, multiple CPX, multiple WIPs, ingresses, right? And so each WIP is assigned to that ingress that you can use.
Okay.
Yeah.
All right, thank you.
Sure.
Okay, any more questions? If not, then thank you for coming, everyone.
Thank you so much.